The final utility program that we are looking at is the sort. And the JCL requirements here are, we have a sort lib, which we can optionally use if we need to point to the library that the sort program resides in. Generally, this is already addressed by having that library be part of the general system search, so this would not normally need to be coded. We have a sort in DD statement that identifies the input data set to be sorted. We can have a series of sort in statements where the XX is replaced with a sequence number in the event that we want to merge a bunch of different data sets together in a sorted order. A sort out statement identifies our output data set. Then we have our sysout for sort messages, and then we have sort work data sets, which are optional. And the optional in this case is in the event that we don't have enough processor memory due to the size of the data sets being sorted, we may need these optional work areas in order to be able to perform the sort itself. Generally speaking, this is no longer going to be a requirement unless the data sets are exceptionally large. So for the most part, they can be left off. Now in our example here, we have included them just to illustrate how they would be coded. Notice that in this case here, we've designated 5 sort work areas. We could allocate significantly more than that if we needed the space because of the large sort. But in this case, you'll notice we don't have to specify a dataset name or a disposition or anything else. Instead, we are simply identifying the device type, in this case a disk, and then the amount of space that we want to assign. This allows the sort program to dynamically allocate up to 5 temporary work areas that can be used to hold information while these files are being sorted. The sort in and the sort out indicate our input and output data sets respectively, and then our sysout indicates the sort messages, and then our sysin DD* represents the control statements that we are passing to the sort program. The control statements themselves indicate the nature of the sort, what type of sort, what are the fields that we want to sort, and in this example we include a mod statement which identifies sort exits. So essentially with the sort fields, what we have then is that we are indicating that we want a sort operation. The field statement itself is defined as the position, what the position of the data is, how long that particular field is, what the format is, such as character or binary, and then the sequence, ascending or descending order. Then from here, the equals value indicates that if we find records that have the same values, then we want to simply process them in the order in which they were received. The mod statement, where we are dealing with the exit, involves exits where the sort may be invoked from within a program, or they may be external to the sort program itself. The E15 exit is an input sort and the E35 is an output. And so basically what happens is when we have the exit, the data may be processed or something done to update it or modify it or filter it before it gets passed as input to the sort program. And similarly on the output side, we can do the same thing with data that's returned from the sort, where we can edit or modify or even remove it. So basically these external exits then, or from within our program, are going to be these input and output exits, which in sort terminology is considered an E15 and an E35 exit. Now in the previous example, what was coded there was in fact documented as a requirement for the particular product that we were sorting the data for. So unless you have written an exit, or unless you have a specific requirement to invoke an exit, the only time you would code those statements is when directed to by a vendor product or by documentation. Beyond that, the sort field statement will be sufficient to sort whatever information that you want. There's nothing additional added by the E15 or E35 unless there is specific external processing that needs to be invoked. So in general now, this sums up all of our JCL as well as our utility programs that we've been discussing throughout all of these different modules. At this point, you should have a reasonably good idea of how to code up the JCL statements, what a job looks like, what a proc looks like, and how these different items can be invoked, as well as how they can be maintained, how they reflect the various utility functions, which of course is going to be carried forward in applications that you may have to write JCL for. In addition, looking at the utility functions allows us to perform some basic actions without the necessity of writing our own programs to do that. We can take advantage of these utility functions then as a standard set of tools that we can use then to perform these actions in batch using JCL.